So to summarize the pigeonhole principle, if there are more birds than houses, then some of the birds will have to share a house. Another way of saying that is one of the houses will have 2 or more birds. Now there is a technical definition right here that relies on the formal notation of a function, and basically it's saying that one function from one finite set to another finite set cannot be one-to-one. In chapter 7, we'll talk about finite functions and we'll describe a little bit more what it means to be one-to-one. But for now, just remember, if there are more pigeons than there are pigeonholes, then the pigeonhole principle applies, and some of the houses will have more than one pigeon. Again, we don't know what house will have more than one pigeon, and we don't know how many pigeons there will be in that house. They could be, again, all together in one house, or they could be kind of spread out with one of the houses containing 2 pigeons. Okay, so let's think about example 2. It says, in a group of 6 people, must there be at least 2 or more who were born in the same month? So in that case, the answer is no. Okay, why is it a no? So in this problem, the n we're talking about is the 6 people. So there are 6 people. However, the m in this case is 12 because there are 12 months. So if you have 6 different people, they don't have to be sharing the same birthday month, right? If you had, let's say, 13 people in the group, then in that case, yes, because the first one, let's say, is in January, the second one is February, and so on and so forth. Well, the last person has to be one of the months that we already described. So in that case, the answer will be yes. So in this case, the n will be 13, and the m will be 12. And again, 13 people and 12 months, so the pigeonhole principle will apply. Okay, so when we have 13 people and 12 months, the pigeonhole principle does apply. But if we have 6 people and 12 months, the pigeonhole principle does not apply. Okay, why is it applying in one case and not the other one? Keep in mind that n has to be larger than m for the pigeonhole principle to actually work. So in this first problem, n is not greater than m. As a matter of fact, it's smaller. However, in the second case, n is larger than m, so that's the reason why the pigeonhole principle is applying. Okay, so if you think of it, you can think of it like this. There's a function going from one set to another set, and what the function is basically doing is saying person 1 is born in January, let's say. Person 2 is born in February, let's say, and so on and so forth. The person 13 is going to have to go back and be born in one of those months. We don't know which one it's going to be, if it's January or February or March or whatever, but we know that that guy is going to be sharing a month with somebody else. So that means the function that we're describing is no longer going to be one-to-one. So in this case, the function assigns a month to each person, but at least 2 people would have to share the same month. Again, we don't know which 2 people, and we don't know which month it's going to be, but we just know that 2 people at least will have the same birthday month. Okay, so that's the end of that part. Okay, we'll do the next part in a separate video.